security principles. So information security, it's really important, right? So as you're developing your product, your information security team must be engaged. Remember, this is what I was telling you before for your DevOps, right? DevOps does not begin when the product is being developed and they're done and handed over. DevOps has to begin at the very beginning of development, because as a part of the development, you have to implement, you have to include your information security team as a part of that development, or it's going to cause more problems down the road. Guaranteed. Okay. Now, the other key point is that security does come at a cost, and it's always this balance between ease of use, response time, and security. Now, quite honestly, if your system was the most locked down system in the world, chances are, and it could be the best system in the world, right? You can have the most secure system in the world, and what you decided to do to make it the most secure system in the world is I didn't connect it to the internet. Well, let's see how long people are going to keep purchasing that tool. So the answer cannot be, I'm going to remove it from the internet. The answer has to be, I have to balance my security concerns with my operational needs to kind of create the most effective tool. There has to be a balance, all right? But however, there are a number of principles that you can apply to reduce the risk, okay? Now, I'm going to give you another access to a tool that I think is really key in this area. And it's the only tool that I'm aware of that does something like this. So, and it's called HashiCorp Vault. I put the link in the message box for you all to kind of go to. This is an open source tool. And while we can't get into all the specifics of it, but I've used it and it's pretty powerful, and I'm only beginning to kind of scratch the surface of it. But what it does is that it allows you to take, it's going to read right here. It secures, stores, and tightly controls access to information or secrets that you need. So this becomes very powerful because it manages users as well as machine access to different information. And additionally, it allows you access, it does all your certification management. It does network encryption as a service. It does credential management for AWS and a few other ones. Various databases, and it fits credentials plus a lot more. I mean, it's a really powerful tool. I've set it up. It's really user friendly, but ultimately, what it does is that it allows you to kind of protect information, and it's a real powerful tool that kind of allows you to do that. If this is something that someone's interested in, I would recommend that you kind of. It again is open source. But they do have an enterprise version as well, i.e. you pay for life. Really what you're paying for in this case is mostly their expertise, not as much as the product itself. Okay? So anyway, but this is a great tool that kind of helps you implement the things that we're talking about. This is one of them anyway. And again, there's other ways of doing it. Again, I'm all about just kind of introducing you to tools, and you kind of figure out what works best for you and your organization. Other principles. So one key principle is this notion of defense in depth, okay? So you see this diagram on the right-hand side, but ultimately what it is that it is the practice of arranging the defensive layers so that you can defend each layer, where each layer is independent of the previous layer. So in this case, the way we're looking at it is that you have a person at the very top that's trying to get to your internal application server. So in this case, I set a strategy of defense in depth, trying to isolate that even if this person gets through the firewall, it doesn't mean they have access to everything else. They still got to work their way through my DMZ, i.e. where my web server is. My web server has been hardened. It has all the virus scanners on there and so forth. All of the file permissions, the access control list, etc. So they have to get through each individual layer in order for me to get to the application server, the application server. So when you set it up where just because they get through one thing, they don't get through the other, that is a defense in-depth way of engineering your security system. And this is one of the more common ways that they're engineered. So if you get through a firewall, doesn't mean you have access to everything else. Because you get through DMZ, doesn't mean you have access to the internal firewall, right? So everything is layered to ensure that once you get access to one thing, you don't get access to the kit and caboodle. So Balagi said, please elaborate on the DMZ. So, I mean, in DMZ, they often say demilitarized zone, right? Normally, it's like a buffer area, really from a military standpoint. It's like a buffer between your place where you live and the enemy. So you have this, like, matter of fact, so let me give you a practical example. Like, I know at least in the United States, you hear a lot about Korea, right? So between North Korea and South Korea, there's this DMZ, this demilitarized zone that nobody can kind of go into. What it does, it gives you a buffer between you and them. Principally, this DMZ is the same thing that you see here in defense in depth. It's like the buffer between the outside and the inside. All right? But got it. Excellent. So in this buffer, in this case, this is where you're going to kind of put some more checks in to make sure nobody's getting through this not supposed to get through. In this case, you have access control lists. You have HIDs, what it's called, but essentially all that is like virus scanners and things of that nature. And then you have a hardened build that kind of shuts down ports, shut down unwanted network access, all kind of things, right? So this is your DMZ. All right. Any other questions? All right. Moving on. So moving on with defensive depth, okay? So interestingly enough, 80% of website vulnerabilities come from this thing called cross-site scripting. Cross-site scripting, right? So what is that? So often you may hear of these things called attack vectors, all right? An attack vector is just that. It's just a way that people can use to get in. That is an attack vector. The more you reduce attack vectors, the more secure your system is, okay? So this attack vector called cross-site scripting, it accounts for over 80% of website vulnerabilities. And really, all it is like this in the second bullet. An email or website contains a link to another website, right? So it could be like they put this harmless link. Matter of fact, you may see it, right? Like you go to your page and you click on a link, or you go to some web page, and then they have all these pop-ups. If you go to Yahoo, for matter of fact, let's go there, because Yahoo is notorious for having them, right? So you go down here, and some of these are valid links to a web page, but every once in a while, like, probably better said, like you see these pictures over here on the side over there, they'll have these different advertisements that come up, and one of them might say, hey, find out what this person did, right? like this one here. Millionaire urges Americans to get out of cash now, right? And I'm not going to click on it because I'm always kind of weary about links like this. But what it is, potentially, that could be a cross-scripting link. It looks like one thing on this page, but if you go to it, it kind of kicks off some JavaScript that performs some function that allows your system to become compromised, right? That is what cross-scripting is. It looks like one thing on your web page, but when you click it, it does something else, and then it kind of provides it causes other issue on your system. Cross-scripting. All right. So in this case, clicking on the link causes the browser to execute some code. And in the email case, and then it allows them to kind of email sensitive information. I mean, it could be a variety of things, right? Another case would be that a web server stores raw user data. And then because of the way they engineered it, because they failed to implement proper escaping mechanism. And escaping is kind of like this. Characters, there are some key characters that every language has. And like, for example, if you were to do something like this in Bash, if you look in your text box, those quotation marks means that it's a string. So really, what it's saying is that the string begins with the letter J, right? But if you wanted this quotation mark to be a part of the string, I would need to do something like this. I would need to put these, what they call escape characters, in front of I just put it on the text box. I would need to put these escape characters in front of the quotation marks so that it's included as a part of the entire string. So sometimes when you fail to properly escape things, you cause your system more failures. You enable people to do things to your system by simply, in this case, by not properly escaping the things that you should, right? Okay, so let me go back to the big screen now. Other things you should do, again, we can talk about defense in depth. Now, you should also try to minimize your attack surfaces, right? So you have to minimize the number of points into your system. That's your goal. And that's what you should be about. In whatever way you can do that is, you should do it. So one of the most common ways of minimizing attack surfaces is updating your browser, updating your OS. People are figuring out things all the time, right? And the more you can update things to overcome attack surfaces, the better. Because a lot of times updates are based upon overcoming security issues, right? So one of the more common ways of minimizing attack surfaces is updating your software. And that includes updating any applications you're building. The same thing happens. You build it based upon some principle. So you want to make sure that you're not allowing these vulnerabilities into your system. Now, there's another concept called fail secure, right? So generally we say you want to fail secure versus failing safe. When building an application as a general rule, you want to fail secure versus failing safe. So let's start with failing safe. So if in this case you have a door, and if the power shuts off, right, you're gonna instead of everything shutting down, the door is going to open. That's failing safe. Or if you look at it from a software standpoint, if you have a function that checks for nulls, for example, check for nulls, check to see something is empty, you'll fail safe if you don't, if it fails, or if it breaks, it still continues. That could be failing safe. Or probably better said, if it fails, if it's a null, you put another value in there that could be failing safe. Whereas failing secure is with the door mechanism, if the power fails, the door locks. All activity ceases. So the question is, the point is, systems should fail secure versus failing safe. So let's look at this question. What happens when a store's connection to a credit card validation system fails? So if you go to a store, you give the person your credit card, they swipe it, and then the store's connection, whether it's the store or whether it's the actual server on the other end, the connection fails. What should happen? Well, so I think everybody was here for a moment. They were trying to figure out how to download this. I think if you go to File, well, actually, so I went back to our links where everyone kind of take a look at it. If you go to File, and you can download as whatever, and it'll allow you to download. Okay, that's how you download. Somebody asked a question earlier, and they want to make sure I kind of covered that. But either way, this is a great link. While we can't spend a lot of time talking about in great depth because we got a lot of things to cover, I did want to point out that there's where's that? Right here. In this link, and I'll put that link here. Put it in the message box. But this is a great page that covers this concept in great depth. I would recommend that you kind of take a look at it because again, it does a bang up job of explaining very specifically why what we're talking about is important. But in short, to answer this question, what happens when a store is connected to a credit card validation system fails? Ultimately, what the store has, what the credit card has to deal with is if a connection fails, if that's the error, then if they allow people to come in and approve many things, or if the store's connection fails, that could be one problem. That if the error, I guess what I'm saying is that the error has to be very kind of clear to a large degree. And they should, in this case, they should fail secure. In other words, shut the door, nothing else works. Because if not, it opens up possibilities for a lot of fraud, and it opens up possibilities for, what's what I'm looking for? Not only just for fraud, but for liability. That's what I'm trying to say. Liability, and it puts a lot of liability on the store versus the people providing the service. Because, so my point is, in order to prevent that, what they do instead is that if it fails, we're just locking everything down altogether, i.e. we're failing secure. Okay? All right. Other key concepts. Least privileged. Rocky, any questions? Any questions? All right, we're cooking, man. All right, least privilege. All right, so as a general rule, you only want to give people the minimum privilege they need in order to do their job. You don't want to do the max. Because I found, even in my own personal experience, quite honestly, I find that really I only need access to a handful of things from day to day. Very rarely do I need access to all things, right? And so by granting least privilege or the minimum privilege needed to do their job, it's going to improve security, stability. It's going to require not a least amount of testing, and it makes deploying everything easier because I can just do the minimum. And what I also talked about, just to throw it out there again, is a notion of minimum viable solution or minimum viable product. What is the minimum thing I can do to still meet the requirements? And that's what I want to do. And here's a good example of this. A backup system only needs read access to the data it's backing up. It doesn't need to be able to write to the same directories where it's that it's backing up. Just doesn't need that. So don't do it. Don't give it to them. Least privilege access. And then another point to think about is security through obscurity, right? Right, just simply hiding something doesn't make it more secure. I think we all kind of understand that. Like, for example, often one technique that developers have used, and I've been guilty of myself, quite honestly, is I'll create a link and make a way for anybody that has this link to access this data. Well, if I'm going to do that, fine, not a problem. But if I'm doing that and I'm saying it's secure, I'm incorrect and I'm wrong, right? Just because it's hidden, for most people, doesn't mean that it's more secure. Listen, so what are some common ways they do that, right? They take a web server, and put it on another port. Well, it doesn't mean that it's more secure. It's just not in the same place that it was before. Right? Generally, another important point, they say, well, just because I use cryptography means that I'm securing my information more. Well, it used to be a time where government employees used to be the only cryptographers. Well, guess what? That's not always true anymore. Right? There are a lot of cryptographic algorithms that are published now. And so if you do the right one, potentially a lot of people may have access to it. Matter of fact, I think, anyone recall that article that Google just published about some cryptography, something that they've broken? Does anyone recall that? Y'all know what I'm talking about at all? No? Well, okay, yeah. So there was Google put out a link or a paper that described how they went about breaking some level of cryptography. And it took them like some number of weeks to do it with all their computers. So my only point being is, just because you encrypt it doesn't necessarily mean that it's also secure, right? So hiding it and things of that nature isn't the way to say that my system is secure, right? The way to do that is by having good authentication, good authorizations, good auditing. That's how you're going to implement a solid and secure system. All right. Additionally, right, using modern languages. I can't stress this enough. Like I love, well, let me phrase that. I would say I love C, but that's not entirely true. I I use C and I enjoy using it just because it allows me to do more about what I want to do. But the absolute truth is that C, when you use that language, it opens you up to more security problems. Well, why? Because it allows you to perform more lower level functions. Well, doing that isn't necessarily a bad idea, but the problem is that a lot of these languages like Java, Kotlin, and a few other ones, they have a lot of the security things already considered as a part of their core language. So when you say perform a go get command, they've already taken consideration that if it's a null, make sure you error out. If it's a buffer overflow, make sure you error out. If you see this, make sure you do this and that, right? So using an up-to-date language is really key. So Ritesh and Balaji, they kind of some key points. Memory crash issues, absolutely with C, yes. Balaji talked about Java heap size issues as well. Yes, excellent point, Balaji. Absolutely. These are all things that that are part of the reasons why some of these things are used, but it also points out some of the reasons why certain things still happen, like having a proper Java heap size. That's important in that it allows you to. It doesn't break the application when your Java heap size, which is kind of a place where Java instructions run in your Java heap. So it has to be a certain size to allow for a certain level of performance and for Java code that runs. Ritesh brought up memory management is allowed in C. Yeah, exactly. And that's one of the lower level functions that I was talking about, right? So these lower level languages, they can be good, but they allow access to doing things that could really be harmful to your system. So if you're using these systems, chances are these languages, well, chances are you're aware of that. However, you always have to kind of be aware of some of the things that kind of go along with it, right? So, to the best of your ability, you want to use modern languages. Additionally, you want to make sure you keep it simple, right? Just because it's complex doesn't mean that it's the best. And it's been proven that simple solutions, they have fewer security risks. Why? Because the security portions of that are often more well understood. And then just simply having a complicated solution, often just even understanding the why something fails is problematic. I have a system that has probably about 30,000 lines of code. And I hate that system because anytime something breaks, I have to go through like this big process to figure out why it broke. And I hate it because the code is so complicated and it's outdated on top of that. So we're using a lot of we're in Java 1.8 now primarily, although there's Java 1.9. But we're still using like Java 1.5 ways of doing things, and sometimes doing that is just takes a lot of space and it's very complicated. So anyway, overcomplicated solutions often have obscure failure paths. So gold plating can be an issue. Gold plating can be an issue only from the sense of extending, because remember, gold plating is this notion of taking a requirement and adding all these unadditional things that doesn't bring value. That's what gold plating is. So gold plating can be a security issue if it's not well thought out, and or if it was kind of just thrown in there, if you would. So often candidates for issues are things that went beyond the initial requirements and someone just kind of added on their own. Those are prime candidates for where things go wrong. All right. Any other questions? All right. So SendMail has a very cryptic and complex configuration file, and I've seen this before. It ran 80% of mail servers in 1996. It ran 24% of mail servers in 2015 in favor of easier to configure alternatives. Yes. So like having, just because you have a configuration file that's, let me show you. It's probably easy just to show you. Well, no, I'll tell you. So SendMail, all that it is that it would, yes, it's a mail application. That's all it is. Yes. Like Outlook. Right. All right. But specifically, you can take Outlook and put it on multiple servers. But in order to configure SendMail, it was largely dependent upon configuration files. Right. I was about to, and where I was about to go was like they used to have SendMail. You can access it online as well. So, all right. Now segregation of duties, right? So if you don't do this, I guarantee this will cause you problems as an organization. As a general approach, you don't want all of your eggs in one basket. You want to make sure that there are clear lines of segregation of duties, and you have critical functions that requires multiple people or multiple entities to work together to accomplish it. So, for example, probably one common way of doing this, if you got a data warehouse, what you don't want is one person to have access to all of your databases. So what you might say, in order for anybody to access your data warehouse, there always has to be two-person integrity. Two people are required to go in and work together to accomplish some goal, right? That could be a segregation of duties. So this notion of dividing critical functions into steps and or processes or number of people to accomplish a specific goal. All right. Now, another thing, trust and complete mediation. Trust. All right. So, all right. So trust mediation is when two parties you exchange credentials and then it required no further checks. That's trust and complete mediation, right? So, whereas complete mediation is where credentials are checked on every access. All right. So often systems, they're going to generate some kind of time-based token. Like, for example, with Gmail, well, probably a better example is for most of the time when you're operating Windows initially, that if you're not moving your mouse around for some amount of time, it's going to reduce. It's going to log you out, right? That's that same principle is the same notion for a token. This token is going to be authenticated and authorized for X amount of time, and then it has to kind of be re-verified at some point, right? And so often those are ways to do that. Like I showed you that HashiCorp Vault, it does that for you. That's one of the things that it does. It has the ability to require that when they present their token, they present it once, then they have X amount of time to access to do their job, and then after that, it makes them re-verify everything again, right? So that's one thing that it does. Last one is single sign-on is an incentive compromise, right? So one of the ways that they kind of do this is that it's an acceptable way of working through this is single sign-on. And this single sign-on kind of allows you to, it kind of avoids the need for multiple passwords. So like for Google, for example, you have a single sign-on. And this single sign-on, they have this family of tools that you now have access to, right? But with that, they also give you the ability to have two-pass sign-on or two-factor authentication, right? And so one of the ways to do that is that you not only got to put in your username and password, but it sends a text to your email saying, "Hey, I'm trying to log on. Click yes to allow you to log on." And then so that way they kind of two-factor. That's two-factor authentication. Okay. But single sign-on is a common way of compromise to kind of work through this trust and complete mediation. Okay. All right. With that being said, we're going to hit our first break. Are there any questions? Any questions? All right. So before you go on your break, we're going to implement the polls. We're going to open up the polls for you. Please complete the polls as a part of the class. And we're going to go ahead and take a 15-minute break. If I can have you back in your seats ready to go at time 5 minutes, 15 minutes from now, we'll go ahead and start 15 minutes from now, okay? All right, go ahead and go on a 15-minute break. If you could also put a little coffee icon, that way I know you're on break. And if you have any questions, again, just let me know. All right, so again, we're on break, so again, 15 minutes from now. While we're on break, I'm going to ask a few questions. Jerome asked, I'm hearing new principles like secure DevOps. Is there additional security manifestos added with what we are discussing now? That's a good question. Generally, I've heard of secure DevOps, but I haven't seen anything formal that separates the two in any great lengths. I do think that the implication is that secure DevOps, they're focusing on the security portions of the DevOps, but I don't necessarily think that it's any different per se. It's just that your focus is different. Like there are DevOps that focus on release management. You don't necessarily call them release management DevOps. That's just they're considered part of DevOps. Whereas secure DevOps, I think they're focusing more on that security element. All right, don't reinvent the wheel. Again, we're still talking about security, right? And so the whole point of this slide is to kind of talk about, don't try to necessarily come up with your own security solution per se, right? While solutions should be tailored to meet your specific need, but you don't have to reinvent the wheel in order to ensure your security concern is met and your security risks are mitigated properly. So use existing and known and reliable security software suites, right? You don't have to recreate your own to make this work, right? The Unix, the TCP/IP stack has been around a long time. It's stable and reliable. right? You don't have to try to come up with your own protocols in order to communicate, right? Use what's there and what's available because we understand all the security implications around it. Additionally, that's similar to saying, like, you have a need to communicate via messaging to in order to ensure that your team can collaborate. Well, there really isn't much value if you're going to create your own messaging system when there's like so many other options that are available. Why do that? Why waste the money to develop it when you can, quite honestly, open source things that are free or at very little cost and accomplish what you want done in a better fashion and in a more secure fashion, right? So, take advantage of what's been done already. A lot of times, other operating system vendors implement their own stack, right? And these had vulnerabilities which had been discovered and fixed in Unix, right? So the point being, make sure that you, as much as possible, leverage what's already been done versus creating something new. Now, passwords. Passwords, as you know, are problematic for a lot of organizations. But really, so Balaji, you mentioned the fact that as a part of what we're talking about, knowing reinvent the wheel, network-related concepts are also part of the DevOps model, which includes switches, routers, and they absolutely are. You're right. It is a part of that. So there are some templates of things that have been done already. And those things that have been done already, they work for certain use cases. So what we don't want you to do is go create a new firewall because that's what you want to do, right? Take advantage of the firewalls that are already in place and use those. And unless there's a reason not to use it, then you definitely want to talk about those reasons. But again, things where thousands of eyes have taken a look at something and taken a look at it to see if there aren't to verify and vet any security risk. Those are good tools to use and good starting points. So your passwords, right? So many people have very, very insecure passwords, and they do things like throw their names in there. They have kind of their address, all kinds of things. Well, while you can do that in unique kind of ways in order to make it secure, but for the most part, you definitely want to put in policies that allow for secure and strong passwords, and not, that check for certain things like, birth dates, that checks for people's names and things of that nature as much as possible in order to ensure a secure system. Now, in databases, oftentimes, passwords are not stored, or they shouldn't be stored in plain language in a database. They should be stored generally as a one-way hash, meaning that you can go from, once you put it in, it takes it, and if you would, multiplies it, your password times an integer. That's a cheap example, and it's really kind of simple. But the point being is that multiplication will only work one way, right? So if I wanted to go the other way, I have to do something else to make that work. In this case, I would need to divide it by something, right? Generally, as a good rule of thumb, when you store passwords in databases, they should be stored as some type of one-way hash. They're converted going in one way. I couldn't take that same way and convert it on the way out. I would have to perform a different function in order to figure that out. Okay. All right. Securing passwords. So SALT. Earlier we talked about. We threw out a few tools out there. Some of them included Ansible. We talked about Puppet, and then we talked about Chef. Just a few of the ones we talked about. But specifically in our case, we're looking at SALT. Those four systems that I talked about, Ansible, Puppet, Chef, SALT, they're all kind of these management tools, these system management tools, configuration management, IT management type system, I think what they're officially called. So SALT is a tool that can be used to help obscure passwords. And the way that it does it, it takes random fixed size numbers. So if you would, it'll take an integer that has 10 characters or 10 digits, and it'll take those 10 digits and it'll randomize those and add it to your password and store that with and store in that store with the resulting hash. So in the way to do that, by doing that, it reduces the chance that identical passwords will generate the same hash. Right? So even if they have the same password, like before, if I just can kind of converted a hash by some factor, or a password by some factor, I can, if it had the same hash, it would be safe to say that those two users have the same password. What this does is that when that password is generated, it adds some number to the password, and then by doing that, it ensures that the password won't, the hashes for those different users won't match. So that's what that's about. So there are ways of making secure but memorable passwords. Like often, just kind of give you a thing that I do. On a QWERTY keyboard, for example, I may take a pattern and say, this is going to be my pattern for this, this year. And then my pattern, I just kind of move from places on the keyboard. And then my starting point on the keyboard is a little different, but it's the same pattern. And I use combinations of shifts and controls and all kinds of things. But nonetheless, the point being, it makes it very memorable to remember what my password is for a particular system. Another way is take two short unrelated words and put numbers and symbols in front of them, right? And these words and symbols could mean something to you. Like for example, my number for the year might be 42. For me, in the United States, there was a baseball player named Jackie Robinson. Jackie Robinson wore the number 42. And so I may say, my number for the next 5 months may be his number. And then I put a combination of things together to kind of meet the complexity I need in order to make sure my long passwords are both secure. All right, so Secure ID. So Secure ID is a tool. So Ritesh asked the question before I move on, how do you memorize such complex passwords? Well, the way that I memorize complex passwords is really either by patterns or by what they call them, pneumatic memory devices. The word will come to me in a second. What I do is I'll take these concepts of the way things connect, right? The way one thing you could do, you might say, I have a sister and she's 36. So I may say, in 36, and then what I might use is that this time I might use 1936, 2036, 2136, and that might be my entire password. And the only reason I remember it was 36 was because of my sister, right? So you got to find a way to kind of take a hold of those complexities. And use these memory devices to remember what they are. All right. Secure ID. All right. So this is a common way that people use, particularly in businesses. I see it a lot in businesses where they'll have something like this, and they have this little key fob, and it generates a random number at some periodicity. So this is called secure ID, and it's often used for remote authentication. So it usually is the issue with the device that has this number that's generated at some periodicity. And then what happened is that the user is going to authenticate with their PIN, and they're going to authenticate with this secure ID. So there's apps for this kind of stuff now, like let me see if I can find it real quick. Like if we were to go to Google, Google.com play. And yeah, so this Duo mobile app, and just so everyone can have it, I'll put this in the chat box. This is one that kind of sets up principally the same kind of thing, the two-factor authentication that I was talking about earlier. And essentially what it does is that it's going to generate like this random number, as you can see on the right of the screen over here. It's going to generate this random number, just like right over here. It's going to generate that random number, and then you're going to use that as a part of your authentication. So that's one way but principally it's the same thing as the secure ID. The server that this app runs on, it's going to have a clock and a database of seeds for each supported secure ID. So for each one of these secure IDs that someone has, it's going to have a database entry for it. Now, with this, the clocks can get out of sync, but you can go to the server and adjust it to make sure that everything is in sync with the device and with the server, so that when you put in your PIN plus this number, the secure ID, it'll have that on there. All right, some other ways of authenticating is through biometrics, right? So you can have some of these authenticating factors, fingerprinting, retinal scans, face recognition, voice prints, typing patterns, etc. Now, while some of these things are, and there's apps that do a lot of these things, quite honestly, but nonetheless, these tools, while they're still not as expensive as they used to be, but if you were to implement this at an organizational level, it still may present some financial difficulty in implementing this across the entire organization. Often, what they do is for the more secure areas that they need to hold people accountable, they'll create more biometric points of entry that authenticates you by looking at some key biometric figures. So many organizations will have information security teams, right? And they all kind of play a role in reducing the risk associated with security and ensuring compliance throughout the organization. But I want to say this, and I think it's important and it's worth repeating, that it's very important that the information security teams are engaged as a part of production or a part of developing your tool set. And the earlier you engage with them, the better off your team is. I really can't stress that enough, right? And so engage them as a part of this process. Don't treat them as if they have the bubonic plague, which is not good.
Hey, want to become an expert in cloud computing? Then subscribe to Simplilearn's channel and click here to watch more such videos. To nerd up and get certified in cloud computing, click here.